Week 2, switched on circuits. Let's take a few notes. These will be some terms that we will be using for week 2 in switched on circuits. So let's go ahead and get some of these filled out. I will be giving you some time in between the definitions to fill in the words. If I start to go faster than what you can get them filled in, you can just press the pause button, get your information filled in, and then start again. I will attempt to give you enough time in between to get things filled in though. All right, here we go. The first one is circuit. A path for an electrical current to flow around. A circuit is a path for an electrical current to flow around. Go ahead and fill in path, current, and around. Okay, let's look at the next one. Open circuit. An incomplete electrical circuit in which no current flows. So an open circuit is an incomplete electrical circuit in which no current flows. Go ahead and fill in the words incomplete, circuit, and no. Okay, let's go ahead with the next one. Closed circuit. A closed circuit is a complete circuit through which electricity flows. So if it's closed, it's complete. If it's open, it's incomplete. Okay, so go ahead and fill in those two words for closed circuit, complete and flows. A closed circuit is a complete circuit through which electricity flows. All right. Short circuit. A short circuit is a connection that allows current to take the path of least resistance. Okay? This is a connection that allows current to take the path of least resistance. So a short circuit is not necessarily going to be a shorter path, but it's going to be a path where there's not as much resistance. Let's go ahead and get those four words, connection, current, path, and resistance filled in. two more here. We have fuse and circuit breaker. Fuse, a safety device with a thin metal strip that will break if too much current passes through a circuit. All right, so this is a safety device. A fuse is a safety device, and it breaks and causes the current to no longer have a closed circuit to flow around. So let's go ahead and read this definition one more time, then you can get filling it in. A safety device with a thin metal strip that will break if too much current passes through a circuit. Go ahead and fill in the blanks there. 6 words. All right, and the last one, circuit breaker. Circuit breaker is a reusable safety switch that breaks the circuit when the current becomes too high. Both a fuse and a circuit breaker will cause the flow of electricity to stop. The main difference between a fuse and a circuit breaker is that a fuse, when it breaks, it's not reusable. A circuit breaker is very similar to, maybe you've even heard the term, oh, we blew a breaker in our house and someone has to go to the breaker box and flip the switch back on. So those are reusable circuit breakers. So when the current becomes too high, the circuit switches off and you have to go back down and switch it back on. So those are reusable. So go ahead and fill in the definition for circuit breaker. A reusable safety switch that breaks the circuit when the current becomes too high. A reusable safety switch that breaks the circuit when the current becomes too high. Go ahead and fill in those 5 words: reusable, switch, breaks, current, and high. Okay, at this point, if you have not got this page all filled out, I want you to press pause, get everything filled out completely and correctly, and then you can press play and continue on with the rest of the video in the second page of notes. So as I said, if you need to, press pause. If not, here we go. Let's continue on to the second page. The second page talks about circuit symbols, okay? As we proceed through this class, we're probably going to encounter these circuit symbols and maybe even need to use them some. So let's take a look at the symbols that are used within electricity to represent things. This is the first symbol. It is a line with a little circle and a line and a little circle and a line. This symbol means open circuit. Okay? And in addition to circuit, I should write there switch. So along with open circuit, it is an open switch. When this switch is open, then you have an open circuit. So I'd like you to go ahead and fill in open circuit, but also put the word switch there because this switch actually makes the circuit open. So this does represent an open switch. The next symbol is a light bulb. This circle with the X inside represents a light bulb. Go ahead and fill in the word light bulb. Next, we have this circle with an M inside of it. And this is the symbol for a motor. At some point during class, I will definitely pull out a small motor and show you a motor within a circuit. So let's make sure we know that the circle with the M inside of it stands for motor. The next symbol we have here, which is sort of a rectangle with a line going through it, is the symbol for fuse. And if you remember from the first page of notes, a fuse is something that breaks when the electricity going through it is too high, and it is not reusable. So this fuse is not reusable. So go ahead and write the word fuse in. Our next symbol here, very similar to the one above it, but there's no angled line or anything in between, and this is a terminal. In other words, this is a place where you could put a light bulb or a motor. Okay, this is a terminal is sort of a place where you can hook in one of those things. So go ahead and write in the word there, terminal. Next, we have just this simple line. This simple line represents a wire. Nothing too complicated, just a simple line represents wire. So go ahead and fill in the word wire there. Next, we have this symbol with a longer vertical line and a shorter vertical line. And this symbol actually represents a battery. Okay, this represents one battery. So go ahead and fill in the word battery there. The next one is a closed circuit. As you can see, if you compare it to the first one we did, that is an open circuit or an open switch. This one is a closed circuit or a closed switch. So we also need to write in the word switch there. Okay, so make sure, you can probably fit yours in a little better than I did, but make sure that you put closed switch. When a switch is closed, it will most likely make the circuit closed as well. So that should have switch there as well. Okay, so make sure you get those two words switch filled in for those two examples. Okay, here we go. We're going to look at, these are not on your paper, so I'd just like you to follow along with me in the video now. You do not need to draw these because we're going to do several of them. I just want to show you some examples. In this example here of this drawn circuit, we have several things. Oh, I guess I was going to ask you, is this circuit open or closed? Will the light bulb light? And the answer is no, the light bulb will not light because of the open switch on the right-hand side. You see, if we start at the top there and we go clockwise around, we have a battery at the top, an open switch on the right-hand side. On the bottom, we have a light bulb. Nothing on the left-hand side other than wire. And this circuit is open. This is an open circuit because of the open switch. So no, the light bulb will not light because the electricity will not be able to flow around. Let's look at the next example. Get rid of that no. Here's our next example. Let's look at it. Is this going to light? Is the light bulb going to light? We have a battery at the top, a closed switch on the right side, a light bulb on the bottom, and again, a plain wire going around the left side. Will this light bulb light? If you said yes, you are correct. The closed switch makes it a closed circuit. Okay, so let's bounce that yes out of here and look at another example. Here we have two batteries at the top. Do you notice how there's two batteries? I wanted to make sure I showed you an example of this. The more batteries there are, the more battery symbols there are. So here there are two batteries. On the right side there is a light bulb, and on the bottom and the left are just plain wires going around. Will this light bulb light? If you said yes, you're correct. This light bulb will light. There is nothing in this causing the circuit to be open. This is a closed circuit with two batteries and a light bulb. Our last example here, if we're going to go clockwise, we will say at the top there are two batteries again. On the right side there's a motor. The bottom is plain wire. The left is a light bulb. Will the motor and the light bulb light and run? The answer is yes. There is no parts of this circuit that cause it to be open. So this motor and light bulb will definitely run and light, especially because of the fact that there are two batteries, which should give it enough power to both run the motor and light the light bulb. This completes our student notes portion of this week's work. So Make sure you have everything filled in. If you need to fill in those switch words, I'll put them back up there on the screen. Make sure that you know that that open switch, open circuit, closed switch, closed circuit. Okay, I want you to have both of those words in with those blue boxes. Okay, and if you have any questions about the notes, let me know. The next video will be the experiment video.